Hello everyone. Today we're going to solve the problem 7.1, which is the first question or the first problem in the chapter equilibrium. First, let's read out the question. The following concentrations were obtained for the formation of NH3 from N2 and H2 at equilibrium at 500 K. This is a temperature, okay? And the reaction is at the equilibrium state. Now the concentrations of N2 is given, which is 1.5 into 10 raised to the power minus 2 mole, or we can say molar concentration, okay? This 2 is of H, okay? And this is 10 raised to the power minus 2. And the concentration of H2 is also given, which is 3.0 into 10 raised to the power minus 2 mole. And NH3's concentration, which is 1.2 into 10 raised to the power minus 2 mole. Now the question is to calculate the equilibrium constant. So let's get started. First of all, let's write the given values. Okay? But first of all, what is this equilibrium constant? That is, we need to find the value Kc. Kc is the equilibrium constant. Here, we are not using Kp because the concentrations are given, and also when we need to use Kp, they used to give this type of questions like find Kp or calculate Kp. So here they told only equilibrium constant, so we will use Kc. Okay, then let's start writing out the given information. Here the first given information is of temperature. See, we'll write T is equal to 500 K, and the next given one is concentration of N2, which is 1.5 into 10 raised to the power minus 2 mole. And the concentration of H2, we will write it as 3.0 into 10 raised to the power minus 2 mole. And the concentration of NH3, which is 1.2 into 10 raised to the power minus 2 mole. Now let's start solving the question. Now let's write the formula for Kc. Do you know the formula for Kc? At first, I will show you the concept of Kc, of product, okay? Product with their stoichiometric coefficient. Let's keep it as X divided by the concentration of reactants. Okay, if there is there is not only one reaction but there are two reactants, then we'll make other bracket 2, okay? And if there are two products, then 2 we will do the same thing. And here too, coefficients are required. Never forget coefficients. Now let's solve the question. We have the real formula or the formula of Kc with us. Now let's solve the question. They have told to find the equilibrium constant. So here, what is the equation that is given? We are not given an equation, okay? So we will have to find out the equation. They have told us the formation of NH3. Okay, I'll show you. See, they've told us following concentration were obtained for the formation of NH3. So we can derive the equation from this given. So the equation would be N2, which is gas, plus 3H2, which is also a gas, and we'll give the equilibrium sign, okay? We'll give 2NH3. This is the formed NH3, okay? we have written the balanced one. Now from here, see, is there any coefficient with 2 and 2? No. No coefficient, it means 1, okay? 1 is a coefficient, so we don't need to write 1. Here 3 and here 2. So here what is a product? This one, right? This is the product. So let's write the formula of Kc again. Kc is equal to concentration of product. So here only one product has been formed. So we will write NH3. Its concentration, and the stoichiometric coefficient of NH3 is, yes, 2. Divided by, we will write the concentration of the two reactants, which are N2 and H2. We'll write into, we don't need to write to the power 1 because it doesn't change the value. And we will use H2. The stoichiometric coefficient of H2 is 3. Yes, very good. Now we will solve it further. We have given the value of NH3. Its concentration, see, it is what? Here we are changing the bracket. We are keeping the round bracket and we are writing the value of the concentration of NH3, okay? That is 1.2 into 10 raised to the power minus 2 m. We don't need to write this unit, okay, m. It's not required. So we'll just cut it. And then divided by, this is to the power 2. Don't forget the coefficient, okay? And then this also will change the bracket. And 2's one is what? 1.5 into 10 raised to the power minus 2. And H2's, see, its coefficient is 1, so I'm not giving anything because 1 doesn't change, or it doesn't matter if you write it or not because it's always there. H2's value, its concentration is 1.2 into 10 raised to the power minus 2 m. We will not write the m. And its stoichiometric coefficient is 3. So we're writing here 3. Now we're solving the question, okay? And we're gonna get the answer. That is 0.106 into 10 raised to the power 4. Now let's move on to it further. We will get 1.06 into 10 raised to the power 3. So this is the value for Kc. I hope you all understood the answer. See, from this we again exchanged is like we just changed the decimal point. We kept 1 point, okay? This is the value for Kc. We got it simply, right? See, this is really easy. And there's one thing to note. It is, you should keep the square bracket because it shows what concentration, okay? It shows what concentration? It shows molar concentration. After we write the value of the concentration or the molar concentration, we don't need the square brackets, we need the round brackets, okay? These points are to be noted. See, easily we can find all the answers